All right, so we're going to talk about theoretical probability, which is different from experimental probability. So before, when we talked about experiments, that was when we did stuff like someone's doing something like a person or medicine or in gambling or something. Okay, so it's a situation where there's human elements involved. When we're doing theoretical probability, it's situations where there isn't really a human element involved and everything's fair, it's equal. So the examples we have are dice, cards, spinners, and coins. All of these don't really have human chance. Every card in the deck is equally likely. Heads or tails is equally likely. So because of those, we can set up this special type of probability called theoretical. So let's look at experimental. If I rolled the dice 100 times and I got the number 6 20 times, my probability would be 20 out of 100, okay, which works out to 20%. This is how many good outcomes I got. So I got 6 20 times, cool, and then 100 is the total. When we do theoretical probability, it's a little bit different. The top number is what we want. So if we look at a normal dice, okay, 6 sides, right? There's only one 6, so the top number would be 1. The bottom number is still the total. It's how many different outcomes are there. So if I look at a dice, there's 6 sides, so the total will be 6. Let's do a couple more examples so this makes more sense, because this is what we're trying to do now. We're not doing any experiments. If I flip a coin, how many outcomes are there? There's heads and tails, so there's 2 outcomes, so that's the bottom. If I want to know what my odds of getting heads are, there's only 1 heads on a coin, so it's 1 out of 2. If I'm doing a spinner, let's say this is my spinner, okay? And I want to know what's the probability of me spinning green. So if I look at my spinner, how many sections are there? Well, there's 4. How many sections are green? 1. So my probability is 1 out of 4. If I'm doing a deck of cards, let's say, okay, and I want to know what are my odds of getting a king. So first we need the bottom number. So in a deck of cards, there's always 52 cards. That's how many there are. If you want to think how many kings are in a deck, it's 4. So the probability is 4 out of 52. And again, you can turn it to a percent, but that we talked about that before. This is the basic first step. Okay? Again, we're not doing experiments, so we're not testing a deck. We know that decks are fair, and we know that spinners are fair, we know that coins are fair, so we don't need to experiment. We can just, in our minds, come up with these probabilities. Okay? You can also change it. So for example, if I was doing dice, what are the odds, what are the chances I'll get an odd number? So the odd numbers are 1, 3, and 5. So there's still 6 dice outcomes, but 3 of them are good, so the probability would be 3 out of 6. So probability trees are really weird. It's when you do 2 events in a row. So for example, what if I flipped 2 coins? Okay, so what we're going to do is we're going to make like a branching tree that shows all the outcomes. So we start here. When I flip a coin, there is a heads or there is a tails. Now, when I flip the second coin, after each outcome we have to draw again, there is a head or there is a tail. There is a head or there is a tail. So let's just say I flip my first coin and I got a head. Then when I can flip my second coin, I could get a head or I could get a tail. So when you look at it, there's actually 4 outcomes here. You could get head head, head tail, tail head, or tail tail. Okay? By following the 4 different paths. The way we can find out how many total numbers there are, we can take the probability, so whatever it was 1 out of 2, right? We can take that number and then multiply it by itself. So squared, so that's going to say there's 4 outcomes. Now, that isn't a big deal. We don't really need to know that. Being able to draw this tree is important and follow it. So for example, if I flip 2 coins, what's the probability that I'll get 2 heads? So first of all, I need to know the bottom number. So when I look, well, there's 4 outcomes here, so that's the bottom number. And then I look at all the different outcomes. How many of them are heads? Only 1. So the probability of head is 1 out of 4, which is 25%. Now let's say instead I want to know the probability of at least 1 head. Okay? The bottom number is still 4 because there's still 4 outcomes. But when we look at those 4 outcomes, how many have at least 1 head? This one does, this one does, this one does, this one doesn't. So the probability is 3 out of 4. So by doing this chart, you can actually see all the outcomes and figure it out. Now, the coin example is pretty easy. This is the dice example, which you can see is a lot weirder. So we start from here. It's sideways. It's the same idea. We can roll a 1, 2, 3, 4, 5, or 6. Okay? And then after each dice roll, you could again roll 1, 2, 3, 4, 5, or 6. They've written here in the chart for you, which makes it a lot easier, the sum. Because a lot of time with dice, you want to know the sum. So let's say, what are the odds of getting a sum of, I don't know, 3 when you roll 2 dice? So let's do the bottom number first. We need to know how many are here. So if you counted, it's 36. The easier way to count is there's 6 here, and 6 times 6 groups is 36. Now, how many 3s are there? There's 1 right here, there's 1 right here, and there's no more in the whole thing. So the probability would be 2 out of 36. Now let's say, what are the odds of the sum being at least, I don't know, 10? So now let's go through and let's see which ones are 10 or greater. 1, 2, 3, 4, 5, 6. That's it. So the probability, the 36 is still the total, it's still 36. But in this case, we said there were 6, so the probability is that. Now, this chart, you should have access to it. You can find it online. This is a picture of it. It's really helpful. Being able to draw it out just takes a long time, but you have the skill to do it. There's one more situation I want to talk about when you're playing cards. Okay. Before we dealt any cards, here's my deck of cards. Okay, there's a lot of them. What are my odds of getting a king? So like we said before, there's 4 kings and there's 52 cards. That's probability. But now let's say that I drew some cards. Okay, so I drew my hand. My hand has 4 cards. Okay, and there's like a jack, an ace, a jack, and a queen, whatever. Okay, now what's the probability that the next card will be a king? There's still 4 kings in the deck, so it's still 4. But the bottom number, I have 4 cards in my hand. So that means there aren't 52 cards left in the pile, there's actually 48. Okay, and then let's say I drew a king as my next card. What are the odds that the next card will be a king? So now there's only 47 cards left in the deck, but there's actually only 3 kings because I got one of them. So when you're doing probability with cards, it is very complicated, but the idea is just remember, this bottom number is how many options are there. And in a deck of cards, after you draw some, there's not 52. There's usually a little bit less. And that's it.